industry-specific distributions. When the variable that you want to specify consists of a continuous distribution, the first question you want to ask yourself, even before searching for hard data or expert opinion, is whether there are industry-specific distribution functions currently being used in a certain field. Examples are abundant. For example, as we will detail further later on, the log-normal distribution is quite common in the oil and gas industry. It describes variables which are highly skewed to the right, which means that large values of x have much smaller probabilities than values of x in the opposite direction. Log-normal distributions describe that are products of other variables. For example, if we were to define oil reserves with the formula N equals A times H times R, where A and H and R represent drainage area, net pay, and recovery respectively. These variables themselves are usually also described with log-normal distributions. Even more so, therefore, its product N for reserves would then constitute a log-normal distribution. By definition, a random variable x has a log-normal distribution if its natural logarithm is normally distributed. Like the normal, the log-normal requires two parameters, the mean, mu, and the standard deviation, sigma. Values for a log-normally distributed variable extend infinitely in the right direction. However, a log-normal distribution does not allow for negative numbers. Another common distribution is the gamma one. It is frequently used to model waiting times. For instance, in life testing, the waiting time until death is a random variable that is frequently modeled with a gamma distribution. More than distributions that exist by themselves, many continuous distributions make up large families depending on how their parameters are defined. For example, the Erlang distribution with a shape parameter is a special case of the gamma distribution. It is the distribution of a sum of k independent exponential variables with mean equal to lambda each. The Erlang distribution was developed by Norwegian mathematician A.K. Erlang to examine the number of telephone calls which might be made at the same time to the operators of a switching station. This work on telephone traffic engineering has been expanded to consider waiting times in queuing systems in general. The distribution is also used in the field of stochastic processes. Nowadays, the Erlang is a dimensionless unit that is used in telephony as a measure of offer load or carried load on service-providing elements such as telephone circuits or telephone switching equipment. The beta distribution is a family of continuous probability distributions defined on the interval 0 to 1, parametrized by two positive shape parameters denoted by alpha and beta that appear as exponents of the random variable and control the shape of the distribution. The beta distribution has been applied to model the behavior of random variables limited to intervals of finite length in a wide variety of disciplines. A very simple yet useful distribution is the exponential. It is, in its simplest form, the exponential distribution has only one parameter, the location parameter lambda. It can be used to describe non-negative geophysical variables at a fine time scale, that is, hourly or daily rainfall depths. In addition, a theorem in probability theory states that intervals between random points in time have an exponential distribution. Application of this theorem in geophysics suggests that, for instance, the time intervals between rainfall events have an exponential distribution. This is verified only as a rough approximation. We could extend on this discussion endlessly. Remember that At Risk comes with a robust help reference that can be retrieved by clicking on the Help button for each distribution function. You will get additional documentation for each distribution function briefly describing its usage, its mathematical notation, and their functions for various statistics. We suggest the following book as extended reference material.